FSR Redstone is launching today, and it's a bit disappointing. AMD are calling this their new era of gaming innovation, but the frame generation feature is partially broken, and all the new features are exclusive to RDNA 4 GPUs. I'm going to mostly focus on the frame generation stuff today, but if you were expecting this to be a massive overhaul that brings AMD's technology in line with NVIDIA's, I don't have particularly good news for you. But before we get into it,
today's video is brought to you by UGREEN and their Nexode 65-watt travel charger. As part of the Nexode Pro series, this is an ultra-slim fast charger delivering exceptional 65-watt charging in a credit card-sized form factor. This is the ideal travel companion as it comes equipped with interchangeable US, UK, EU and AU plugs right out of the box, making this the only wall charger you'd need to take abroad. This little unit packs a punch with 65 watts of efficient, super fast charging at the 2.0 spec, allowing for a 50% MacBook Air M2 recharge in 30 minutes. Equipped with a pair of USB Type-C and a single USB Type-A port, you can plug in 3 devices simultaneously with the intelligent GaN Infinity chip handling the rest, ensuring fast, safe, and cooler charging. If you happen to be jet setting over the New Year period, we would highly suggest considering one of these, so for more information, please check the links in the video description.
So FSR Redstone is a collection of AMD features and technologies that are launching under the FSR banner. You already know about FSR 4 upscaling, which launched earlier this year. This is part of Redstone, but for some reason, AMD are rebranding it as just FSR upscaling, no longer mentioning the version number. There's no updates to the tech here either, it's the same FSR 4, just with a new name for Redstone. The new stuff begins with FSR frame generation, a new AI-powered version of the technology that utilizes a machine learning model for improved visual quality. There's FSR ray regeneration, a neural network denoiser for ray tracing that's designed to be broadly similar to NVIDIA's ray reconstruction, and there's FSR radiance caching, which uses a neural network to store and reinterpret lighting information for accelerated ray tracing performance. In what will be disappointing news for owners of previous generation Radeon GPUs, all of the key Redstone technologies are exclusive to the RX 9000 series and RDNA 4 architecture. This includes AI-powered FSR upscaling and frame generation. There were some rumors that Redstone would be developed to support older architectures, but this is not really the case. It's officially for RDNA 4 and future architectures only. For some of the technologies, this means there is no fallback for RDNA 3 and older. FSR radiance caching and ray regeneration are not available in any form for older architectures. With FSR upscaling and frame gen, there is a fallback option, but don't get excited, this is not some new technology. It's an FSR 3 fallback path, which AMD label as the analytical version, distinct from the newer and better ML version. Essentially, the status quo is being maintained. Owners of RDNA 1 through to RDNA 3.5 can access existing FSR 3 technologies, while RDNA 4 gets all the new ML-based Redstone stuff. The biggest disappointment here is that AMD are not launching FSR 4 Int 8 as part of Redstone. We know the Int 8 version of FSR 4 upscaling exists, AMD published source code for it, we tested a compiled version, and found it worked really well on RDNA 3 and 2. It's a great fallback choice given FP8 instructions, used for the full FSR 4, are not available on those architectures, but Int 8 is available. As things stand right now though, this is not an option. The fallback choice for FSR upscaling is the old FSR 3 analytical model, and there is no word from AMD about whether FSR 4 Int 8 will ever officially launch, though of course you can use third-party methods to get it running for yourself. Despite all of that, Redstone is still interesting because we are getting multiple new machine learning powered technologies for those with the latest hardware. Ray regeneration is already launched, it's available in Call of Duty Black Ops 7 multiplayer, and with this official release of Redstone there are no changes or further updates. The official ray regeneration launch title is Black Ops 7, the version in that game is the launch version and it's not available in any other games yet. So if you've seen other videos on ray regeneration, you know what to expect and we'll look at it soon. FSR radiance caching is not available to test yet at all. AMD says this technology will be available in 2026. This leaves us with FSR frame generation with the new ML-powered model, which has the broadest release of any new Redstone feature. Essentially, this works like FSR 4 upscaling. AMD's latest driver includes a toggle that performs a driver upgrade of FSR 3.1.4 frame generation up to the new ML-based version. Provided a game has already integrated FSR 3.1.4 or newer, the toggle is available. So we're getting around 30 supported titles at launch, including major releases like Cyberpunk 2077, Black Myth Wukong, Hogwarts Legacy, and Black Ops 7. Developers will also be able to integrate the new Redstone version into games directly, though as of today, all supported titles are via the driver upgrade system. The problem with FSR Redstone frame generation is that it doesn't work very well, and that's because of frame pacing. AMD's frame generation tech still suffers from poor frame pacing, something we flagged 2 years ago at the original release of FSR 3. As far as I can tell, this is still a problem with FSR Redstone, and I don't believe the Redstone update itself has made any improvements to how frames are delivered to the display. The easiest way to explore frame pacing is a real-world look at the output on a monitor filmed with a slow-motion camera. This gives us a look at how frame generation delivers frames to the display with features like adaptive sync, aka FreeSync, enabled, the default and recommended configuration for anyone gaming today. Direct captures through the Radeon software screen recording feature do not show how frames end up delivered to the display, and capture cards with fixed refresh rates don't necessarily show the issue either, at least to the same extent as you see on a real monitor. So to properly assess real-world frame pacing, I recorded some footage at 960 FPS. First up, let's look at Black Ops 7 as an example. Here we have frame generation off, so this is the default experience, and I've configured the settings such that the game runs at about 60 FPS at 4K. What you'll see here without frame gen enabled is a very consistent delivery of frames to the display. The frame rate does fluctuate slightly around that 60 FPS mark, but with adaptive sync enabled on a Radeon GPU, the interval between frames is consistent, and this leads to a smooth output. When we enable FSR Redstone frame generation, now the output becomes choppy and juddery. Instead of each frame being perfectly paced, one frame is quickly followed by another frame on the display, creating a double tap effect where consecutive frames have alternating short and long intervals. You get 2 frames quickly, then a longer pause, another 2 quick frames, a longer pause. Occasionally, FSR frame generation seems to be able to create a smoother and more consistent output, but throughout most of this test run, we see poor pacing. And it's not just when spinning the camera around, which is the easiest way to see this. Here's an example of this judder when simply walking forward with frame generation enabled. And now let's look at how DLSS frame generation runs in this game, swapping out the Radeon RX 9070 XT used previously for a GeForce RTX 5070 Ti. Same in-game location, but the output from Nvidia's frame gen is much smoother and more evenly paced, leading to a much more pleasant experience in-game. The judder seen previously in the Radeon output is noticeable in real life despite this footage being captured at nearly 1000 FPS, and the smooth output on the GeForce card is definitely better. But it's not just this game where I experienced issues. Here's God of War Ragnarok using FSR frame generation with a juddery double tap output. Here's the same game in the same spot at the same quality settings running DLSS frame generation. Note that whether VSync is on or off makes no difference to the frame pacing. In this case, we're using VSync off for both FSR and DLSS examples. Here's Hogwarts Legacy, exact same issue with frame pacing, and Hogwarts on the Nvidia GPU with DLSS frame generation. Here's GTA 5 Enhanced Edition. You'll even spot some screen tearing in the FSR frame generation output despite FreeSync being used. Here's that game using DLSS frame generation at the same settings. Here's F1 25. This example is a bit more subtle due to a higher frame rate overall, but if we slow the example down, you'll see the same sort of frame pacing problems. And here's that game running on a GeForce GPU with DLSS frame generation enabled. Here's Cyberpunk 2077, same problem with FSR frame generation and a corresponding smoother output with DLSS frame generation. Now, this doesn't appear to be an issue in every single game I tested. Mafia: The Old Country is more consistent using FSR frame generation than the other examples, with an output that is quite similar to DLSS frame generation. Black Myth Wukong isn't too bad either, a bit of choppiness in parts, but certainly a lot better than some of the worst examples I showed earlier. But at the end of the day, I looked at frame pacing in 10 supported titles with FSR Redstone frame generation and found frame pacing issues in the majority of them, while those same games using DLSS frame generation were smoother and more evenly paced. As a sanity check, I ran FSR frame generation on a completely different system and setup. After all, it could be something to do with my specific test machine. So I put a totally different GPU, this time the Radeon RX 9060 XT, into a totally different system with no shared parts and hooked it up to a completely different display. The same problem presented itself in Cyberpunk 2077 and F125, confirming that this is not isolated to my main test system. The problem here seems to be relatively straightforward. FSR frame generation is not properly delaying the generated frame output. Take an example at a 100 FPS render rate with a final output after frame gen of 200 FPS. The GPU is rendering frames every 10 milliseconds, and then generating an additional frame somewhere between those other frames for an ideal final output of a new frame every 5 milliseconds. What the frame generation system needs to do is wait 5 milliseconds after displaying the rendered frame before it shows the generated frame, and then wait another 5 milliseconds before showing the next rendered frame, and so on. That's how you get nice frame pacing, and seems to be what Nvidia do with their technology. At 200 FPS, you get each frame delayed such that they are always about 5 milliseconds apart. Instead, if you're generating a frame and you're getting that delay wrong, or you don't delay the frame at all, you get a choppy output. Generating a frame takes much less time than rendering a frame, so if you displayed both generated and rendered frames immediately, you'd get a horrible mismatch in pacing. In our 100 FPS example, if you sent out the generated frame, let's say 1 millisecond after the rendered frame, you'd have to wait another 9 milliseconds until the next rendered frame, and this creates an inconsistent timing between those frames. Couple that with a modern adaptive sync monitor whose goal is to display the next frame as soon as it's ready, and you get that choppy output with the potential of tearing. And this is not something that can be solved with VSync on, because adaptive sync monitors in that configuration still show frames as soon as they are ready. Where this inconsistent frame pacing seems to be most noticeable with FSR frame generation is on monitors with a high refresh rate, the exact sort of display that should benefit most from this technology. Displays that refresh quickly can show uneven frames more quickly, amplifying the visibility of judder. Lower refresh monitors by nature have longer delays between each frame, which can help to hide the uneven pacing, though it does make the output more prone to tearing. While I did most of my testing on a 4K 240Hz monitor, the frame pacing problems were even more noticeable on, say, a 1440p 540Hz display. I don't know how FSR frame generation currently handles frame pacing internally. I know back with FSR 3 they had some unusual approaches to this, but the current result is a lack of proper frame delays and so a poor frame pacing outcome. AMD are aware of my findings here. I got access to FSR Redstone on Friday of last week. I emailed them about the frame pacing problems on Saturday. They acknowledged my report, they're looking into it, but they're yet to respond with any sort of findings or potential solutions. Given these problems have lingered since FSR 3, I would be surprised if there was a, say, simple fix for this, like a driver setting or something. Currently, I believe this is an inherent flaw with how FSR frame gen works. Now, the whole goal of frame generation is to improve the visual smoothness of the game output. We know frame generation does not improve performance or latency, but it can create a smoother output that's more pleasant to view with reduced display blur and greater clarity. That benefit is defeated entirely if the frame generation output is choppy, the complete opposite of smooth. So once I discovered this problem early on, my enthusiasm for any further testing of FSR Redstone frame gen did evaporate. However, I want to briefly touch on the image quality of the technology, just in case AMD are able to solve the frame pacing problems and make the tech properly usable. Here's Mafia the Old Country running at 4K 120 FPS, so 60 to 120 FPS frame generation, using quality upscaling from both brands, captured on an external capture card. Now you might be wondering how we were able to capture this footage without frame pacing problems. That's because if you use a fixed refresh rate instead of adaptive sync, lock the frame rate to exactly the same as your monitor's refresh rate, and then force VSync on at a driver level, you can stabilize the output. However, this is not a practical way to play games, and it may not be achievable in some configurations. You may just not be able to get your FPS high enough to reach your monitor's refresh rate, so it's a test sort of configuration only. As with previous frame gen investigations, we're playing back this footage at half speed so that you can see every frame. What's immediately noticeable in the FSR 3.1 footage is flicker in the car's shadow. Redstone frame generation cleans this up significantly to give a much more stable shadow that's in line with DLSS frame gen. With FSR 3.1, this is a super noticeable and very distracting artifact during normal real-time gameplay at 120 FPS, so the better stability you get with FSR Redstone is much appreciated. There is still some garbling on every second frame with tricky shadow detail like the spokes in the tires, but this is much harder to spot than the overall shadow problems with FSR 3.1. I also noticed in Mafia that FSR Redstone does a great job of handling trees in motion, whereas these elements are quite garbled using DLSS frame gen. So that's a clear visual win to AMD's technology. And while grass is blurrier using FSR, there is much more frame-to-frame consistency than you get with DLSS, suggesting frame interpolation is behaving more accurately. In God of War Ragnarok, FSR and DLSS trade blows visually. In this first scene, the textures on the back of Kratos are more stable in the FSR image than DLSS, the latter of which can be a bit garbled in motion, but in this next scene, DLSS has greater stability around the axe as it moves position, and in some frames, Redstone was actually a bit more garbled than FSR 3.1, which is interesting. In F125, it's another battle. DLSS frame gen is superior at preserving ground textures. With FSR Redstone, every second frame is quite garbled in terms of the road. FSR 3.1 has significant issues with shadow stability, as we first saw with Mafia, which is fixed in Redstone. The newer ML-based FSR frame gen is also superior at interpolating fine details like the antenna and pitot tubes at the front of the vehicle, which have much more ghosting in the DLSS image. DLSS also struggles with rendering the UI, which is put into the frame generation algorithm on the NVIDIA side, but is ignored with FSR and rendered at half rate, which is better at preserving details. Here's Hogwarts Legacy with a running test, and what's interesting with this example is that each frame generation technology displays artifacts at different times. At each specific point in the stride, you might find one frame gen tech looks clean with perfect interpolation, while another has garbling and disocclusion problems. Switch to a different frame and the technology showing the artifacts is different. In general, FSR 3.1 has the most artifact problems, but Redstone isn't in the clear either, and at some points it does a worse job of preserving details than FSR 3.1. Next, we have a particle test casting some spells, and this is a really tricky thing to interpolate. DLSS does the best job here, but FSR Redstone isn't far behind and interpolates the particle effects well with not too much flicker or blur. FSR 3.1 has the most flicker, similar to what we see with shadows, and looks the worst overall. In Call of Duty Black Ops 7, again we see the technologies trading blows. FSR 3.1 has the most flicker and instability in areas like blood and particle effects. This is much improved with Redstone. In other areas it depends on the specific frame what sort of issues we see, but I think AMD's technology gets pretty close to DLSS. Lastly, a quick look at Cyberpunk 2077. This is the worst showing for FSR Redstone. The visual output seems broken in this game, with lots of blur and grain that is not present in the 5 other games I explored. DLSS frame gen clearly looks better in this title with much better stability and less blur, so I'm not sure what is going on there. FSR 3.1 isn't amazing either, so if I had to guess, I'd say this is just a poor implementation of AMD's frame gen technology. But you never know, it's also a different game engine to the others, and it's possible FSR frame gen doesn't work particularly well in this engine. As for output frame rate, FSR Redstone frame generation is not substantially heavier to run than regular FSR 3.1 frame generation, now referred to as the analytical version. In Mafia the Old Country, enabling Redstone caused the output FPS to only drop by a couple of frames. In F125, with an output over 250 FPS, Redstone reduced the output by about 3%, which is not all that significant. And in God of War Ragnarok, Redstone actually runs slightly faster than the analytical version, and this was a repeatable phenomenon. In all of these cases, FSR frame generation has slightly less overhead than DLSS frame generation running on similar hardware. In Mafia, using Redstone, we got a 69% higher frame rate output on the 9070 XT compared to frame gen off, while on the 5070 Ti, I achieved a 61% higher output with DLSS frame generation. In F125, there was a 40% increase on Radeon compared to 38% on GeForce, and in God of War Ragnarok, I saw a 72% increase with Redstone versus 59% using DLSS. So ultimately, FSR Redstone frame generation with the new ML model is not very impressive. This really sucks to see because there's some underlying quality stuff here. Image quality is definitely improved compared to the old basic analytical model, and AMD has achieved this with little impact to its performance overhead. But frame pacing is broken in the real-world configurations I've tried, and this completely defeats the purpose of enabling frame generation in the first place, which is to improve the smoothness of your gaming experience. On a normal adaptive sync monitor, the FSR frame generation output is choppy and juddery in most games, something that's especially noticeable performing camera pans or fast movements. To make matters worse, it doesn't seem like AMD has made any significant strides in frame pacing compared to the original release of FSR 3 back in 2023. I spent a significant amount of time in my FSR 3 analysis going over how frame pacing was broken, and today these issues are even clearer now that I have a somewhat better slow motion camera. It seems that smooth frame pacing is possible at times. It happens in some games, in some scenarios, but it just doesn't happen often enough across the broader sample of titles I looked at with Redstone. This is a significant problem for AMD because Nvidia's DLSS frame generation is consistently smooth in the exact same games. In fact, I wasn't able to find an example where the DLSS frame generation output was juddery. DLSS frame generation just works, so to speak, whereas I've tried loads of FSR frame generation configurations on multiple systems and none of them consistently worked outside of completely locking down the frame rate and refresh rate. In fact, it wasn't really that difficult to come up with these examples for this video. It's not like I went hunting for things where it just broke frame pacing with FSR. In pretty much all games, just fire it up and you can immediately see the problem. Maybe there's some sort of hidden configuration that just gets FSR frame pacing to work nicely, but I haven't found it, and AMD are yet to provide a solution. On a more positive note, FSR Redstone frame gen output image quality is very competitive with DLSS frame generation. We're not looking at identical quality, and there are noticeable problems with both. We're talking about interpolated frames here, so there are visual artifacts, but the Redstone version is typically a significant improvement upon FSR 3.1. There's reduced garbling in shadows, improved disocclusion artifacts, and a more stable, consistent image. I did spot a few instances where FSR 3.1 was superior, but on the whole, FSR Redstone is better and up there with DLSS. What I will say though is that the quality of frame generation does differ wildly between FSR Redstone and DLSS, looking at different games or even different scenes. In one scenario, you might see artifacts that are present in the DLSS output that aren't present in FSR, but then you switch to a different scenario and now there are FSR artifacts while DLSS looks clean. Because you only see generated frames half the time in a single frame gen configuration, the quality differences between DLSS and FSR are not a huge issue, so competitive quality without major glaring flaws is going to be good enough. Based on everything though, if you are at all interested in frame generation, my recommendation right now is just to buy a GeForce GPU. Not because it turns a 5070 into a 4090, it definitely can't do that, but because DLSS frame generation works better, it's supported in more games, and it includes extras like multi-frame generation, which it isn't the most useful technology, but it's something AMD doesn't have at all right now. If AMD does solve the frame pacing problems across all games, I'd say FSR frame generation is a suitable substitute, but right now it just doesn't get close enough. So unfortunately, FSR Redstone is off to a bit of a rocky start. Other than frame generation, we have Radiance caching that won't debut until 2026, ray regeneration in just one game, which we'll look at soon, and FSR upscaling that's a decent feature, but it's unchanged from what we saw earlier this year, including no official FSR 4 Int 8 support. I like that AMD are working on new features like this to improve their graphics software stack. It is sorely needed. However, we're still some time away from Redstone having a significant impact for gamers. So that's it for this one. As I said, AMD are aware of the frame pacing problems that I've talked about in this video. They're looking into it. Hopefully they'll come up with some solution, which of course we'll update you on in a future video or maybe on the podcast, something like that. So yeah, a bit disappointing that we see the frame pacing problems again, but as I said, hopefully AMD can come up with a solution. If you do want to support the Hardware Unboxed channel and all the testing, the independent stuff that we do right here, the best way to do that is via our Patreon page. Links to that is in the description below. If you sign up, you get access to some pretty cool benefits, Discord community, monthly live streams, BTS content, and plenty of other good stuff. So thanks for watching. I'll catch you in the next one.